Greetings to all fellow open source power system hackers. This is Twinbeard, and I am bringing you the one magnet, no bearing Bedini replication that I like to call the FlowerPower Device. We've got pretty much a standard Bedini here with some upgraded components. We've got a 24-point HHO for volts Starship coil. We've got a generator coil on top here, and this is a very high impedance coil, lots of turns of 26, and this is using the Thane-Heinz-Terapatia effect for acceleration. Here's our rotor right here, well, identical to the rotor. Little Neo. That's what the rotor casing looks like, or at least an old one that I burned through. How did I burn through it? Didn't I have proper lubrication? No, I had proper lubrication. It burned through that too. This thing's going close to 2 million RPM. The best I've clocked it at's about 2.4 million, which we're going to try to get it to for this display. We've got a D9203 diode bridge. This is a half-wave bridge, and I'm using one side of this, but this is where our diodes normally are in our Bedini. Our transistor is a 2SK2257 Fuji, and this is a MOSFET with a really great rise and fall times, and it can operate at very, very high frequency. It slams on and off like most MOSFETs will, but we need 4 volts to start it up. So to start this thing up, I have to kind of jump start it with the satellite effect with this larger rotor. So essentially I pull this in, this rotor, I yank it out of here like this, and I put it next to the rotor over here without the generator coil on. I get it going, and then I I put the generator coil on top. Just changing the base resistance just a shade here. Ohmite, RHS 500, 500 ohm, 25 watt rheostat does that job for us. Out of the generator coil, we go to a full wave bridge rectifier, and then we're dumping that into this condenser bank right here. Those are 470 mics at 450 volts. That holds a lot of juice. It'll bite you. Here's our scope trace. I'll lower the intensity just a shade so you can see that. See how many kicks? Would you believe we're on 50 microseconds per division? So we're getting like at least 2 full waveforms per division there, which 50 microseconds gives us a frequency of 20,000 hertz. If it's play with the base resistance here to line this up. If it's 1 division in between wave peaks. However, we got 2 of those, so that should kick us up to about 40,000 hertz. And we got a couple of odd different waveforms here, as you can see. I'm maybe changing 2 or 3 ohms in the base resistance here to achieve what you're seeing. There it's tuned correctly, okay, and it's going to phase out in a minute, but it'll phase back in, and I think it has to do with the wobble of the magnet a little bit. So the magnet's down in there, in one of our little housings, but the fun stuff hasn't begun yet. This is our generator coil output. That's 50 volts per division. As you can see, we got that capped out. So down here we have our Fluke multimeter. We've got that at AC amperes. So what I'm going to do is I'm going to set the camera up over here so you can see it. Extend my little legs on my little tripod. Yeah, we'll do it this way. Alright, here's what I'm going to do. I'm going to pull my generator coil off my bridge rectifier. You'll notice I get a slight voltage drop there, but not a big one when I pull it off. When I pull it off, So now, I'm going to connect this up to my multimeter in series, and we'll see how many amps it tells us. Now what the hell? You see the trace, there's our voltage. You can see there's no milliamps indicated there. 250 amps?
The sea of space, the stars, our limits. We have traveled this way before.
My only explanation is we're operating at a high enough frequency here that we're starting to see some Tesla effects. We're creating enough of a disruption in the ether that we've actually created a vortex going here, and that's kind of grounding itself into this coil. That's my only reasonable explanation for this. As you can see, our output's pretty steady. I'll change the time base here. And it looks like we've got very high frequency waveforms along the lines of those 40 kilohertz waveforms. That's 20 mics per division. And you can see we have about one wave in between divisions there, somewhere around there. But it looks like it's being modulated by a different frequency. Maybe somewhere around 5,000 hertz, 4,000 hertz, something like that. So we have a larger wave and then smaller waves inside the larger wave. That's at 0.2 microseconds per division, which would give us 5,000 hertz. And it looks like we're about one division peak to peak there in our waves. So, can anybody explain this for me? Or have I just, tapped into the universal power source here and now I can light Atlanta off of this thing? Somebody tell me. I don't know. As you can see, there's our condenser bank. We got two motors running. We got this motor running, and we've got this motor running. You can see we got next to no deflection there. We're set at 6 amp scale, 6 is all the way to the right, and that's where our meter needle is. Those are the parts, you know the circuit, that's how it's put together. That's just a loop. And we've essentially got that shorted through the meter. It'll charge those jokers up pretty fast, and they have a nice big kick when they're done. So, thank you all, and I look forward to hearing your replies.